This PowerPoint is on laws of interaction design, and it's meant to help you as you move forward on your project and start designing your mock-up and your prototype. So in the past, we have learned other design principles such as Gestalt laws and also the laws of the psychology of everyday things. So this is a further set of design principles that is meant to guide you as you move into the design phase of your project. Okay, so the first one we're going to look at is Hicks Law. Traditionally, this law is used to encourage designers to limit options in navigation lists and interactive options. So drop-down and fly-out menus with too many options or pages with too many links result in what we call the kitchen sink visibility. So that you might find that familiar as to what we learned in one of the first couple of weeks of this course. The kitchen sink visibility is when you show too many options all at once and there's information overload. So Hicks Law is meant to guide designers to limit these options in your navigation and list. Okay, so you can see here that there's options. Oh, let me just get my laser pointer. So there's options here. So chunking helps to make it so that there is fewer options. So if somebody is interested in, in the store, then they can go look here. So instead of having, 12 options presented all at the same time, you can see that it's grouped so that it looks like it's 4 options presented, and then underneath that it's 3 options. So at any time, it is not more than 4 options presented. Okay, so Fitz Law here is originally developed according to the movement in the physical world. However, in human-computer interaction, Fitz Law is typically applied to movement through the graphical user interface using a cursor or some other type of a pointer, even tapping with your finger. So what Fitz Law has to do with it is the time used to acquire a target is a function of the distance to and the size of target. So that's quite a mouthful. What does that actually mean? So the time to acquire a target, okay, so the time used to acquire a target to get to a target, so let's say this one, this square over here, is a function of the distance to and the size of the target. So let's say I'm over here where Fitz Law is, this header is. So if I'm trying to get to this red box here, that is a function of the distance to, so between here, and also the size of the target, okay? So the bigger this target is, the easier it is for me to get to it, all right? So think about that when you are creating, what is a clickable area. So should only the words be a clickable area or most of that space around that word, okay? So what that also means is that small objects placed too far away from the user's starting position may take the longest to select, okay? The larger a button is, the easier it is to click with a pointing device. As interactive objects decrease in size, there's a smaller surface area requiring a level of precision that increases selection time. So you don't want to have to make your user be extremely precise when having to click on something. Make the clickable area as large as possible, where possible, without interfering with other clickable areas, of course. Okay, so it's something to keep in mind. So Fitz Law also says the outer edges and corners of the graphical user interface can be acquired with greater speed than anywhere else in the display. So for me to click this red square is quite easy. However, if I have to click on the word display in the paragraph, it's a little bit more difficult, okay, than clicking to any corner of this page. Fitz Law also means that pop-up menus better support immediate selection of interactive elements than drop-up menus. So pop-up menus are better than drop-down menus because a user does not have to move from the cursor to its current position, which can cause error. Graphical designs that allow the user to interact without moving help to reduce the travel time. Okay, so again, that's graphical designs. So designs that allow the user to interact without moving helps to reduce the travel time. So don't make your user have to move around the screen too much unnecessarily, okay? Next is the Tesla's law of the conservation of complexity. So the sharing of complexity between the software and the user. Okay, so with any interface or any system, there's going to be a level of complexity. Things are complex. The question is, who should be exposed to the complexity? Should a software developer add complexity to the software code to make the interaction simpler for the user? So should the complexity be the burden of the software designers, so they have to do more coding to make the interface simpler for the user? Or should the user have to deal with a little bit of a complex issue or interface so that the software code can be simple? It's always a balance, okay? The product team should take on as much of the burden of complexity as possible without passing it on to the user. It is the product team's job to deal with the complexity, not the user. It should be easy for the user. Okay, so that is always a debate, right? Or should the engineer spend an extra week reducing the complexity of an application versus making millions of users spend an extra minute using the program because of the extra complexity? So should that engineer, spend extra time on it, or should the users always, even if it only means 5 seconds of extra time for each user, that's times, if there's 1 million users, that's a lot of time being wasted because we're trying to save the engineer 1 week of extra coding. Okay, something to keep in mind. So the example is the email example. So the necessary complexity, the email address of sender and recipient is required. So but you can shift. They have shifted the burden to the email program. You now don't have to type in your email address. When I go to Gmail, I just type in ymound. I don't have to type that whole address in anymore. It remembers the email addresses for me. So that is shifted, that extra work is shifted away from me, the user, to the program. Next principle is the Popup, which is to make a process or behavior error-proof. So remove the ability for users to get to error state. So an example is, the error state will be if you're hiking the Grand Canyon and you might fall off the edge of a cliff, right? Fall off the edge of a canyon. The Popup will be the fence or the rail guard that guards you from falling over the edge. So you don't want that to be even a possibility in terms of user design. So you don't want them to even have the ability to make a fatal error, a bad error like that, right? You want to put something in place so that there's no chance that you would make a really bad error. So that is Popup. So make the process or behavior error-proof. So examples are prevent actions and disable elements. So for example, don't allow to proceed with the registration form unless all the required fields are filled in. Okay, so if your phone number is important for this form, then make sure that the user can't proceed, continue, or go on to the next page without entering that in. Disable the submit button. So make sure they can't even press on the submit button. Is grayed out if that input field is empty. So delete all links if less than 2 items in the list are selected. Okay. So the examples are endless. Next, use a default. So if a user wants to order an accessory from a fashion e-commerce site, you can set 1 as a default value instead of 0. Okay, instead of leaving, sometimes people just click on it and then move on to the next thing. So next is the auto correction. So not having to interrupt the user's experience with known errors autocorrect can drastically improve the application's perception. For example, in the browser, you just type in fdu.com, then the browser automatically enters HTTP, which is needed as a part of the URL. So autocorrection to automatically add information that that is expected to be there. Okay, so next is using constraints. The constraint that I gave in a very dramatic example previously was, the fence or the railing that would prevent someone from falling into the Grand Canyon. So you can restrict the user's inputs, allowing, for instance, only numerical characters or disallowing special characters. So you can have constraints up so they don't make errors. Okay. Next is the magical number 7. So this comes from Miller's original theory that argues that people can keep no more than 7, plus or minus 2, depending on the person, or chunks of memory in their short-term memory. So the first example I showed you was, not overloading information. So instead of having 12 links, you can group them, you can chunk them into 4, and under each there'll be 3 more. So the number is never ever more than 7. So the idea of chunking here. Chunking breaks up long strings of information to units or chunks. So if you have 12, don't present it as 12. Try and chunk them, try and group them into 4 or 2, and then from there you can have further groups. So resulting chunks are easier to commit to working memory than a larger and uninterrupted string of information. So chunking appears to work across all mediums like text, sounds, pictures, and videos. So there are arguments against the magical number 7. Some people say that on a web page, the information is visually present, so people don't have to memorize anything and can therefore manage broader choices. That might be true in some cases, so you don't have to, be a stickler with the number 7. However, I do believe in the kitchen, I do believe in remembering about the kitchen sink visibility problem, where you don't want to display all your information just because you can. It's easier for the eye to see chunked information, to see less choices, and then the eye can go to where it wants to go, that it's interested in, and then look at that chunk of information and look at further chunked information from there. So the magical number 7, when to apply this principle? You may have only moments to look at an interface to extract and memorize important information. You may need to enter this information into systems without the benefit of referring back to the source. We try and not have these situations happen on our app or on our web page, right? However, it might happen. So if that should happen, of course, stick to number 7. Magical number 7. Don't make people have to memorize more than 7 things at a time. And there are also times when you're not allowed to copy and paste information. Then you want to make sure that things are under the number 7. Okay. So the next principle we're going to look at is feedback. We have already talked about feedback in the first unit of the course. Feedback helps to demonstrate the result of a user's interaction, whether or not it was successful and why. It's often used to show if something's correct or incorrect. So if something is loading, or if you're making progress, if something's happening, did I click on it? I don't see anything happening. So that little, round thing going around in a circle, that lets you know that something is loading, something is happening, things are moving forward, instead of seeing a page where nothing happens, right? And then you click and click again, and then you just make everything crash. So it's important to have feedback. Feedback is important because it builds trust with your users. It's a form of communication. It communicates to the user that something is happening. It also helps to add a tactile element to interactions. When there's feedback, you feel that something has happened, okay? And there's also something called feed forward. It's a form of hinting. It's a visual affordance. Think about it that way. So feed forward nudges the users through the correct sequence of actions so they can avoid confusion or better accomplish your goals. So feed forward might be, if you're filling out a survey, or even on our exams, you might see that, there are 10 questions, and then maybe the questions that hasn't been answered yet that are coming up ahead are grayed out, and the ones that you have done are, in black, and then the one that you're currently on is in red. So the future ones are sort of feed forward, right? If you're on question number 5, you can see 6, 7, 8, 9, 10 all grayed out, but then it gives you an idea of what is coming up next, okay? It helps you to prepare people for what's about to happen and what to do. Tell users what to expect. So think about using this in your interface. I find that really helps when I'm filling out a survey that I somehow might have lost interest in, but when I see that number of questions left there, that I'm already on the 7th question and there's only 10 and I'm starting to get bored, then I'm a bit more motivated to continue on, knowing how much further there is to go. So if you have a long task analysis and long series of 28 steps, you might want to let your user know where they are in their step if it's a linear sort of thing, okay? Next is standards. So make sure that you follow interface standards. Okay, so there are standards that you need to follow. Standards, for example, well-known standards like red usually means stop, or there's an error or something is wrong. So if something is good, you don't want to use the color red. Red usually, is alarming and makes people kind of stop and think about what is wrong. So if it's not an error message, stay away from the color red. Red is, globally known as a color that means stop or danger or wrong, right? Or error. Okay, so that's what I mean by example of standard. Okay, so over the years, designers have trained users to accept certain items in certain locations and to do things in a certain way. For example, the keyboard shortcuts like Control-Z, Control-Y means redo, Control-Z means undo, Control-V, Control-C, so Control, right, all these kind of shortcuts that we're familiar with. So stick to those standards. Don't do something different just for the fun of it or just to shake things up. Do what is consistent with standards that people are already used to. So to ignore these standards means your users have to learn something new, and this is what you don't want. You don't want your users to have to use more brain energy than they have to. You don't want your users to have to learn more new things than they have to, okay? So obey standards unless there's a truly superior way, okay? So unless there's a really good reason why red should not mean stop or error in your app or website, make sure that red does mean the standard thing. So new standards don't have to be a radical departure from old standards. It can just be slight changes, okay? For example, the keypad on your phone.